probably just stop.
No, I don't think so.
We almost done with January.
All right, let's review. Take a look. Take a look to refresh your memory on exponents. The next one. Miss Westfall, who's right?
You just say Miss West.
And I will also collect the quizzes right now. Are these quizzes?
Yeah.
You're comparing answers.
No.
Kinda.
I mean, it was a take-home quiz.
Hold on a
Mr.
second.
Parker was saying that was like something like 27 books.
The one thing we said.
No,
was
we're
what?
not. We're not
We're not.
copying.
We got different things.
Look at where your quiz was.
They're cheating, not copying.
No, I
we
was
got
asking a
different
question. I was asking who was right.
What's the one thing you were told not to do?
Not to copy each other.
Not to work with anybody else.
We didn't work together though because we have different answers.
Oh. You're just comparing answers.
Because you.
No, don't burn away. I'll let you know. My goodness. Alright. Here's what I have you do right now. I want to give you an opportunity. Alright? At the top of your paper, you're going to write out a sentence. Okay? And it's either going to say, I got no help from other people on this quiz. I got some help from other people on this quiz. Or, be honest, I copied someone else's work. All right, bless you. It's just between you and me. All right, and
Did your mom tell?
if I'm, you gotta get help from your mom.
No.
My goodness, people. If cheating issues come up and you're honest with us and we'll take care of it, it'd be probably less of a penalty than if you aren't honest with us. All right, I'm gonna have each one of you bring it up. You're gonna bring it up on your own. You're not gonna pass it to anyone else. Bring it up on your own. Turn it in here. Make sure your name's on it. Okay.
I also have Wednesdays.
Just can you show that to me again? We need to get. Does anyone else need to say something?
I gave someone
I think there's rust in here. You see the rust?
Any others?
Yeah.
Did anyone not turn one in?
Do you have a clear plastic cup?
Did anyone not turn one in? Alright, thanks. Alright, we need to go. We need to get going. Alright, so notes. If I write 3 squared, everybody knows that's 3 times 3. Agreed? What do you think a common error is the students make? 3 squared, they write 3 times what?
2.
3 times 2. I agree. Okay. What's 5? What's 5 to the 3rd power? No calculator. Just tell me how I would evaluate it.
You gotta do 5 times 5 times 5.
Very good. 5 times 5 times 5. So this is 25 times 5. It would be 125. Agreed? How about 5 to the 4? 125. 5 times 5 times 5 is 125 times 5. This grows very quickly, doesn't it? Some might even say it grows exponentially.
I know.
I'm kind of joking. Not really. And I'm kind of joking because that expression gets overused. Would you agree with that? Okay. Do you hear, oh, this is exponential. It's just growing exponentially.
No.
Sometimes it's not growing exponentially. You haven't heard that? In the age of the pandemic, you haven't heard it's been growing exponentially. Okay? All right. Is this exponential growth?
No.
That's linear growth. It's a line. Okay. Is this exponential growth?
Yes.
Maybe. Maybe.
It's going by hundreds.
Okay. Is this exponential growth? No. Okay. So just because we see a curve and maybe we see one side of a curve, that doesn't mean it's exponential. Do you get that? Like this curve that I just said is an exponential growth, and we said no, it's a parabola. I erased part of it. Does it make it exponential growth now? No, it's just part of the part of the parabola that we can only see. Right? A parabola is not exponential growth. There's a difference. You'll learn later on what's the difference. All right? You have to have this kind of growth, 5 times 5 times 5 times 5 times. You have to have multiplication growth to be exponential. Okay? I don't want to get too far into it, but that's the essence of it. All right. What does it mean for an exponent to be negative or 0? Well, let's think of this. Ready? Need your help. Let's go backwards. Make me proud. 5 to the 4th was 5 times 5 times 5 times 5. What's that? That was 125, 570, 575. Help me out. Mary? Do you remember how to type in exponents in the calculator? 5, caret, and then 4.
Can I just do 5 times 5 times 5?
Wait, this is a carrot right there.
725 it should be.
625.
Or 625. Sorry, 620.
But it's around the paper, I think. I think it's also around the paper.
Yeah, I want you to look up here right now, though.
Alright.
Thank you. We'll get to it in just a second.
Okay.
I think you guys will learn more from this if we model it first, than to just throw a bunch of numbers on the paper. So just watch up here for now, okay? Everybody ready? 5 to the 4th is 625. 5 to the 3rd we just did. What is it? What did we do to go from here to here? We divided by 5. To go backwards, we divided by 5, right? If an exponent is multiplying by another factor of 5, going backwards, we had divided by a factor of 5, right? Here we go. What's 5 squared? We could just do 5 times 5, or we could divide this number by 125 by 5 and get 25, right? What's 5 to the 1st? 5. What's 5 to the 0?
0.
No. Oh, no. You just told me what to do. How'd you get from here to here?
Oh.
How'd you get from here to here? Divide by 5. How do you get from here to here? 1.
Oh,
5 divided by 5 is 1. Yeah? 4, 3, 2, 1, 0. What's 5 to the negative 1? No.
Oh, negative.
You just told me the rule. Take this number, divide by 5. Take this number, divide by 5. Take this number, divide by 5. Isn't that what you told me? You guys made the rule. Let's keep going. What's 5 to the negative 2?
Or
125th. Ready? Take this number, divide by 5. Remember how you take the denominator and flip it and multiply? When you divide by a fraction, right? So I take 5 over 1, I flip it, and I multiply. That's 1 over 25, isn't it? What's 5 to the negative 3? Good. 1 over 125. What's 5 to the negative 4?
1 over 625.
Do you see the pattern? Okay. So you just learned that that's how we deal with with negative exponents, all right? So isn't 5 to the negative 2 the same as 5 squared, but in the denominator? Right? Isn't 5 to the negative 3 the same as 5 to the third, but in the denominator? And a 1 over top? Okay. So there we go. We just modeled it. This is working backwards, okay? We just showed that 5 to the 0 is, what was 5 to the 0 again? 1. What's 10 to the 0? What's negative 2 to the 0? What's 7 to the 0? 1 every time. Because what's 7 to the first power? 7, and then divide by 7. What's negative 2 to the first power? Negative 2 to the first power. Negative 2. What's negative 2 to the 0? Positive 1, because you divide by negative 2, right? Positive. So really, any whole number, any fraction to the 0 power is 1. Okay. 5 to the negative 1 was 1/5. 5 to the negative 2 was 1/25. Does this make sense? So what is an exponent? An exponent is repeated multiplication. An exponent is repeated multiplication. All right? And we just learned this. We just learned that 4 to the negative 2 is the same as 1 over 4 squared. Do you think it'd be tempting for students to make that negative? I could see that. A number to a negative exponent, they'd try to make it negative, right? So be careful there. All right, 4 to the negative 3. How should we rewrite this? 1 over 4 to the positive third, right? Look at this. Wasn't 5 to the negative 2 the same as 1 over 5 squared? Right? So isn't 4 to the negative 3 the same as 1 over 4 cubed? So what do you get? 1 over 64? Sorry?
Yeah.
What's 7 to the 0? 1. All right, careful with this one. Negative 5 to the negative 4. Isn't that the same as 1 over negative 5 to the positive 4? Take a look at that. Freeze for a second. Take a look at that. Okay, whether you're catching up or trying to work ahead, do you understand this? If a problem has a negative exponent, it's the same as 1 over that number to the positive exponent. 1 over that number, which was a negative 5, to the positive 4th. Do you understand that? What should negative 5 to the 4th be? Positive or negative? Let's think about it. If I multiply the same number 4 times, we know if it's positive, it's going to still be positive, right? What if it's negative? Ready? Watch my fingers. What's a negative times a negative? What's a negative times a negative? And what's a positive times a positive? Isn't it going to be a positive?
Yeah.
Because a negative 5 times a negative 5 times a negative 5 times a negative 5. It's going to be a positive number. Odd. What's 3 times 3?
6, 9, 9.
Positive.
Positive.
So even if it's an odd number, it's still positive. So ready? Watch. Here's what I'm talking about. This is 1 over negative 5 times negative 5 times negative 5 times negative 5. Do you agree? Now, I want you to type this in your calculator, not as negative 5 times negative 5 times. I want you to type it as negative 5 to the 4th. That's going to give us our denominator. And I want you to be careful. And if you're going to make an error, I want you to make it now. But if you make an error, we're going to fix it. Everybody type it in. What's negative 5 to the 4th power? We know it should be positive. What is it?
Negative 6, 25.
Oh, no.
Gosh. Negative? Oh, wait. You didn't put the parentheses.
You didn't put the parentheses. What did it do? Watch up here. -5 to the 4th versus -5 to the 4th. Good morning. Thank you. Your calculator knows order of operations. Please, parentheses, excuse exponents.
Why do you answer?
So wait a minute. There's no parentheses here, so it moved on to exponents. What's 5 to the 4th? 625. Guys, watch. I'm trying to help you out so you don't do a ton of quiz. Do you agree? This way would do the order of operations. It would not do any parentheses. There's no parentheses. It would do exponents. 5 to the 4th, 625. Multiplication next. What's a -1 times 625? -625. What's this one going to do? Parentheses. It's going to do -5 times -5 times -5 times -5. This one's -625. This one's +625. Which one's correct? Second one. This one, you did not use parentheses correctly. The parentheses go around the -5 in that situation, right? So our answer is 1 over 625. Please ask if you're confused. This is letter C. Are you confused on letter C, Logan?
Yeah.
Go ahead.
I don't. Why is it still a negative? Wouldn't I just?
It's not. It's a positive.
No, not the other one.
This one?
Yeah.
Here's what it's doing. It's like, hey, that negative, I'm going to keep it in the back of my head because I'm not ready for order of operations doing multiplication yet. Isn't this kind of like -1 times?
Yeah.
Ready? -1 times, it's doing 5 to the 4th. 5 to the 4th, 625, negative after the exponent. Okay? This one, it's saying I'm going to do the parentheses. I'm going to do -5 times -5 times -5 times -5. This is 25. This is 25. 25 times 25 is 625. Okay? One more way to explain it. This one is 5 multiplied 4 times, then multiplied by a negative. So let me say it again. 5 multiplied 4 times, then multiplied by a negative. This one's -5 multiplied 4 times. Let's see if you guys figured that out. What's letter D? Good. This one's negative, isn't it? What did you do first here? Exponents first. So watch. -1 times, what's 5 to the -4? 1 over 5 to the +4th. What's 1 over 5 to the +4th? 1 over 625. This is -1 over 625. So how do you know whether to put parentheses or not? It'll tell you. It will tell you whether there's parentheses there or not. One of them is negative. One of them is positive. Does that make sense? Be honest, because this confused me when I was a student. Yes? What's -5 to the 0? Aaliyah.
+1.
+1. Type it in your calculator just to be sure. Parentheses, -5, caret, 0. What'd you get?
+1. Wait. Parentheses? Zero.
You said -1 second.
Oh, I said +1.
Did she? It's positive 1. Everybody get positive 1.
So go.
What's negative
And that's here.
5 to the 0? Negative 1. Do you agree? It's going to do 5 to the 0 first, which is 1, and then it's going to multiply by negative. Pretty good? Excellent. Excellent. What if there's a negative exponent, not in the numerator, but in the denominator? What do you guys think? If we took to make this negative exponent positive, we moved it down. If there's a negative exponent in the denominator, it's going to be made positive by moving up. Now let me explain why. Okay? I'm going to change this problem. Are you ready? I'm going to put 1 over 4 to the negative third. Okay? Watch closely. I'm going to keep this 1. I'm going to keep the division. Let's do the 4 to the negative third all on its own. Okay? We already know what the answer is. What's 4 to the negative third on its own? 164. Good. So what's the denominator's value? What is 4 to the negative third? The denominator's value is 1/64. Are you all with me? Type that in your calculator. 1 divided by, parentheses, 1/64. Did you get 64?
Yes.
Did everybody get 64? Oh, that makes sense. Because look, watch what happened. Again, I changed the problem. This is not the original problem. I put the 4 to the negative third in the denominator. Because we're going to see what happens if you have a negative exponent in the denominator. Watch what happens. Ready? That 4 to the negative third became 1/64. But when you divide by a fraction, don't you flip it and multiply? Oh, if I flip 1/64, I get 64. So this is that purple 1 times 64. Isn't that the same result? Watch up here. Isn't that the same result as if I would have taken that negative exponent and moved it up and called it 4 to the positive third power? Isn't that also 64? So good news. Ready? This is the key to this process. If you have a negative exponent, if you want to make that exponent positive, it moves places. This was in the numerator. Now it moves to the denominator and becomes positive. If it was in the denominator, it moves to the numerator and becomes positive exponent. Positive exponent. Does that make sense? Okay? Trading places. Exponent addition. So what's 1 over x to the negative n? How could we rewrite that? How do we make that negative n positive? Move x to the negative n to the top and make the exponent positive. This is the same as x to the positive n. And you can check that with your calculator. What's 1 over 5 to the negative 4? It's the same as 5 to the positive 4 up top, right? Do you agree? Just switch places. Top to bottom, bottom to top. Now the 1 didn't move. The 1's still up there. It's just disguised. Because times 1 is just that. You with me? Ooh, I'm going to make things a little more challenging. Are you ready? What if I change the numerator to prove my point to Elia? Mr. Parker's in here. I have to mispronounce someone's name at least once. Right, Alexa? Oh, Mr. Parker. Ready? Here we go. 2, no calculators. 2 over 5 to the negative 4th. If you believe me, what's this going to be? What's the only thing that has a negative exponent?
2 times
The 5.
4.
Hold on a second. Isn't the 5 the only thing that has a negative exponent? So what's the only thing that moves here? The 5 to the negative 4th moves up. Now what's already up there?
2.
Exponent first. Don't do 2 times 5 first. What's 5 to the 4th?
5 and 8.
625 times 2. 1250.
Wait. Say that again.
All right. 5 to the negative 4th. 5 has a negative exponent. The rule is if you have a negative exponent, you have to move to become positive. Right? Either move up or move down. Well, guess what? It already had a person up there. 2 was already up there. Did 2 have a negative exponent? No, so 2 stays. 2 stays. Well, if 5 to the negative 4 moves up, it becomes 5 to the positive 4, which was 625. We have to do exponents first. 5 to the 4th, 625. Then times 2. Do you agree that's not 2 times 5 first and then raise 10 to the 4th power? That's not the same. Exponents first, then multiplication. Are you with me? Excellent. So again, we have to do something. If we see a 0 exponent or a negative exponent, it is not simplified. You have to address the negative exponent or raise it to the 0 power first. Okay? Let's do a few examples. Does 7 have a negative exponent? No, it's good. It stays. Does W have a negative exponent? Yes. Not good. It needs to move. Does Z have a negative exponent? No, it's good. It stays. Now, do we have a denominator here? Is there a denominator? You could say, yeah, it's 1. It's just not there. Do you agree? It's kind of like down here. I would say right now I didn't see a denominator. So if something has to move, I'm going to have to create space for it. With me? What's the only guy that moves? The W. W to the negative 4 goes down and becomes W to the positive 4. So this new expression, the 7 and the Z, I'm going to write them in black because they stay. The 7Z stay, and the W to the 4th moves and becomes positive. Do negative numbers have to move or just negative exponents? Just negative exponents. We've been dealing with negative numbers all year. We haven't ever moved them to like denominator, right? It's a negative number. Negative exponent, different story. Let it be. Yes?
If there's a negative number, a negative exponent on the denominator and the numerator, do you just swap them?
Yeah, you can kind of treat them separately. Like you can say one of them moves, the other one, like one of them moves down, the other one moves up. Yeah. A to the 0 stays and it gets simplified into what? What's 5 to the 0?
1.
What's 7 to the 0? What's A to the 0? 1. One. B to the negative 2 moves down and becomes B to the positive 2. C to the negative 3 moves up and becomes C to the positive 3. And D to the 6th stays. Can anything be reduced? I don't see any like terms, do you?
No.
Like if I had a 5 squared over a 5, that could be reduced. 25 over 5. Logan? You good? What's another way to write c to the third power? C times c times c. D to the sixth? D times D times D times D times D times D, right? Cool. That'll come in handy soon. Try this one on your own. Anybody want to volunteer an answer to this? Zachary?
1 over x to the positive 3, y to the positive 1, and negative 2a to the positive 6.
All right. I think I'm with you. I think we all agree x to the negative 3 has to move down. Y to the negative 1 has to move down. Does anything have to move up? Nothing has a negative exponent. Do you agree? A negative number is not a negative exponent. Negative 2. What's negative 2's exponent? No.
Zero.
No. No, it's not 0. Negative 2 to the 0, it would have been rewritten as 1. No. Negative 2 to the... It's negative 2 to the first. Isn't any number to the first itself? Guys, listen, you've been kind of looking over it for years now. That negative 2 has an exponent of 1. We just don't write it because it's not helpful. It's just understood to be there, right? That x has a coefficient, a number in front of it of 1. We just never write it. But if it has an exponent of 1, it stays. It's not a negative exponent of 1, right? So the negative 2 is going to stay. The a to the 6th is going to stay. It gets an x to the 3rd. It gets a y to the 1st. And I don't care how you write those, except for I would write the negative 2 first. Because what would it look like if you wrote the negative 2 last? It would look like subtraction, wouldn't it? Okay? Don't do that. What's left up top? 1. Very good. Very good. Do you need to write an exponent of 1 here? No, because anything to the first power is just itself. You don't need to write it to the first power. Okay? Does this one make sense to you? Next. All right, products of powers with the same base. All right. Have you learned this before? 2 to the 4th times 2 to the 5th?
I think
Do you have any guess what it would be? 2 to the 4th times 2 to the 5th. I hear 2 to the 9th.
Would it be 2 to the 20th?
I hear 2 to the 20th. We're just taking guesses right now.
Yeah.
Let's break it down. I bet we can figure this out.
Oh, I see.
What's 2 to the 4th? 2 times 2 times 2 times 2 times 2. What's 2 to the 5th? 2 times 2 times 2 times 2 times 2. 5 times. 1, 2, 3, 4, 5. And these are being multiplied. Oh, so this is 2 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 2 to the 9th, isn't it?
Yeah.
It's 2 multiplied 9 times. That wasn't that bad to figure out, was it? 2 to the 9th. Do you agree?
Yeah.
Let's do the easy one first. What's x to the 2nd times x to the 3rd? X to the 5th. What if you're on a quiz and you forget? What's x to the 2nd power? X times x. What's x to the 3rd time? X times x times x. How many x's do you have multiplied? 5. X to the 5th. Repeated multiplication is an exponent. What's repeated addition? Good. 2 plus 2 plus 2 plus 2 plus 2. You should have been taught in elementary school. 2 plus 2 plus 2 plus 2 plus 2 is 2 times 5. Right? Repeated addition is multiplication. Repeated multiplication is an exponent. Okay? What's a to the m times a to the n? A to the m, that would be times, plus n. Very good. Didn't you just do x to the 2nd times x to the 3rd is x to the 5th? That's 2 plus 3. Didn't you add them? You added the exponent? So m plus n. I got some large blanks down here. 3 to the 2nd times 3 to the 5th is 3 to the 7th. Very good. And let's evaluate that in our calculator. These get pretty big pretty quickly. Huh?
2,187.
2,187 like that. Very good. I have a q to the 3rd times an r to the 2nd times a q to the 6th. Can any terms combine?
Yes.
Q to the 3rd is q times q times q. Q to the 6th is q times q times q times q times q q times q. That's q to the 9th times r to the 2nd. Very good. Can those combine? No, because a q multiplied 9 times and an r multiplied twice isn't going to combine with any. Right? Nothing combines.
Zero.
All right, I'm going to give you a couple options here. You have a choice, all right? Aren't these exponent bases being multiplied together? You could add their exponents, right? Didn't we learn that rule? This could be written as n to the, these two, n to the -1, and then plus 1, which is n to the 0. What's n to the 0? 1. What's another way we could have solved this? N to the 3rd, the n to the -4th moves down to the denominator and becomes n to the +4th times this other n that's up here. Now watch. What is this other n? What's its exponent?
1.
When you multiply n to the 3rd times n to the 4th, you get, nope, I gave it away. N to the 3rd times n to the 1st, you get n to the 4th up top, n to the 4th in the denominator. What's a number divided by itself? Another way to get 1. No matter how we do it, we're going to get 1 here. These are called exponent rules. What about when we divide them? Last thing for today. Here's the way I want you to think of this. Anybody have a guess what this is going to be reduced into? 3 to the 2nd. Here's why. Yeah. This is 3 times 3. Come on. Times 3 times 3 times 3. Yes? Isn't this 3 times 3 times 3? 3 divided by 3. 1. 3 divided by 3. 1. 3 divided by 3. 1. What's left up top? 3 to the
Second.
second, which is. So what? We're gonna have a rule. We'll practice this more tomorrow. Watch what happens. If you divide bases, you know how when we multiplied bases, we added their exponents? When we divide bases, we're going to subtract. 5 minus 3 is 3 to the second. All right? So write that down real quick. A to the m over a to the n equals a to the m minus n. So x to the 7th over x to the 7th over x to the second is x to the 5th. Very good. These are brilliant. Ready for the homework? Page 304, 1 through 25. Elias. Odd. Come on. Have a wonderful day.